I greet you all. This is Biaruhanga Moses, and today let us talk about data types. So in data types, we are having very many ways of representing data, as we talked about in the previous lecture that was introducing us to logic. Here we are seeing that binary information is stored in memory or processor registers. In these computers, the data that is processed is actually stored in a given type. So registers contain either data or the control information. The data is the actual information that is going to be carried, maybe the operations are going to be carried on that very information. For example, you can talk of 2, 3, or 4. Then we have the control information. Control information, these are instructions. For example, add, subtract. That is the control information. So here we have data. These are numbers and other binary coded information. Then the control information is a bit or a group of bits used to specify the sequence of a command or signals, like a command addition, a command subtraction. Data types found in the registers, we have numbers, they can be letters, and other discrete symbols like you see here. For this for a number, this for a gray code. We talked about gray code in the previous lecture. Now number systems, base or radix or error system uses distinct symbols for error digits. We shall look at this in details. Now we looked at decimal systems. Decimal systems are composed of digits from 0 up to 9. So all numbers they fall under this are called decimal systems, so you can call it base 10. So we can any number you see from 0 up to 9, that is decimal or base 10. Now binary system, we talked about it last time, is a base 2 system, and it has either a 1 or a 0. We can't write 2 in this. So these are the binary values that are allowed. So and then we have 1 and 0. Those are the binary digits that we do have. So a 1 is a bit and a 0 is also a bit. When we talked about this one, we said a 0 represents an off and a 1 represents an on. Alright, so let's go to hexadecimal. We said hexadecimal, this is base 16 only because we have 1, 2, 3, 4 up to 16 positions, and that is from 0 up to 15. So in hexadecimal you can't write 10. If you reach on 10, then start on A. We go B, C, D, E, and F. So F represents a 15, as well as A will represent a 10. Similarly, B will give us 11, and so on and so forth. So now binary, we can convert these numbers from either binary to decimal, from hexadecimal to binary, from binary to decimal. We can convert in any way. So let's look at the conversion. Last time we looked at another simple formula to convert. So today let's look at another way to do it. So binary to decimal. So we have this 1, 0, 1, 1.101 base 2, and we want to take it to decimal. So this is base 2 to base 10. So we write 1 times 2, which is this, plus we write 0 times 2. A 2 is a base, that's why we are multiplying it by 2. So plus 1 times 2, which is this one, plus this one lastly times 2. And now when we jump here, we continue. This is 1 times 2, which is this, and then we have 0 times 2, and then 1 times 2. So now let's now put powers. So the powers are incremental from low to high. So where there is a point, the immediate number is in zeros, the next number is in tens, the next number is in 100, and the next number is in thousands. So here this is 0, this is 1, this is 2, this is 3. Okay, so since this one is 0, that means the immediate number following 0 downwards is -1, -2, -3. Good. So here 2 to the power 3 gives us 8, and then 2 to the power this whole number gives us a 0, and then this one gives us a 2, this one gives us a 1, this is 0.5, and then we add. That's when we come up with this answer. We come up with that answer. So this is going to be our answer. Good. So now let's go to decimal to binary. So here we are getting from decimal, we are having a binary number here, but we want to get a decimal number, which is this one. So now let's see whether in a decimal number we can get a what? We can get a binary. Okay, so let's come here. So we have 37 here, which is our 37. So 37, we want to convert it to binary. So 37.375. So now this number, let's divide 37 divided by 2, we shall get 18, and the remainder is 1. So that means we are having this as 1. Then we continue. 18 divided by 2. Let's first leave the 0.0. We know here there is 0.3 what? 0.375. Okay, so let's first leave this. Then we shall see that we have this 1 divided by 2. This division is actually familiar to us. Now let's read the results upwards, and then we give the answer for this. So the 37 alone is equivalent to 1, which is this one here, 1. Yes, we go 0, we are going upwards. Okay, writing what we call remainders. So 1, then 0, then 1, then 0, and lastly 1. So this is base 2. So this is equivalent to the 37. Okay, so now remember that we have a 0.035 to take. Okay, so now this one is going to be a multiplication. So we get 0.375 times 2. This one gives us this. So therefore the integer is going to be 0. We go on, get 0.75, the one we have here, and multiply by 2, you get 1.50. and that means you have